I thought I'd throw out there real fast, if you're starting with Greenplum, 3 good resources to look at.
Thank you.
So I guess in my opinion, when I'm starting to do stuff in Greenplum or there's something, I mean, it has so many features, it's tough to figure out all of them, and I have to go back and reference things. So the first site is the gpdb.docs.pivotal.io, fantastic site, admin guide, all that kind of stuff, good stuff to read. One that not a lot of people know about, if you look for Greenplum knowledge base, the internal tech support guys have a wealth of information out there on Greenplum and like errors you might run into. So do a Google search for Greenplum knowledge base. That's a great way to get more information. And my third favorite site is another guy has a site called Pivotal Guru. A guy by the name of John Roberts has a wealth of information and examples on different stuff to do in Greenplum. So if you're looking for an example of how to do something, he's got a lot of that stuff out there. So if you're new to Greenplum, 3 great resources to start with.
Sounds good. And if you could post those links in the chat, I think that would really make people happy. And in the meantime, Vishal's already got a great question here for you, for us all. The docs recommends the number of segments to not be over 8. Is that primary plus replica or just primary?
Sure. Anybody want? Scott, you've dealt with this one many times. You want to take that?
Yeah, I would say that when you say 8, that's 8 primaries and 8 replicas. So when we're talking about 8, usually that's just the number of primaries that you're talking about. Ideally, the replicas aren't doing a whole lot of processing. So usually when we're talking in just the lingo, we're just talking about our primaries.
And these numbers come from what is current hardware in the market right now. So if you're dealing with the sweet spot of commodity servers that most big data people use is two CPU systems. We call them like 2U or even a 1U, but it's got 2 Intel processors, right? And with that config, over the years and with various amounts of testing, we found that on the average cluster, pretty much 8 segment hosts gives you the balance between network, disk, and CPU that you would want. If you're going down to, let's say, a virtualized system with less cores, then you would probably go down in terms of number of segments. And also, if you're doing mega-sized clusters with, let's say, 200 servers or something like that, then usually people start lowering the parallel.
Is the CPU resources can be evenly distributed just for the primary segments? I'm trying to discern your direct meaning there. Ideally, that's kind of what you're taking into, you want everything to be evenly distributed. So you wouldn't be looking to bundle up like extra secondaries onto one system or mirrors onto one system. Ideally, everything's evenly distributed across the whole system. You have to make sure that, because your mirrors could potentially take over for primaries, you want to have them evenly distributed too. And I would say it's, okay, I'm trying to think. When you say replicas take 0 CPU, I think that's a, so I'm going to say when you're looking at CPU, usually you've got your physical cores, and then you've got your hyper-threaded cores, which give you a little bit more processing. I would say that your replicas are going to take a little bit of CPU. I wouldn't assume that they take 0 CPU. They are going to take a little bit. The other thing to take into consideration is if you have a failover, one of your mirrors or your replicas is going to take over as a primary. So depending upon your level of service, if you're okay that things run slower while one of the replicas take over, then you can go closer to just worrying about your primaries. But if you want to keep your service level at the same level as failures happen, you need to have a buffer for one of those replicas to become primaries within a cluster. So therefore you would want to kind of tweak that ratio a little bit to have some more free resources during normal running that could take on a load when something fails. It's all about your comfort with how much or how well you want the system to run when failures are enacted. Let's see here. Which are the best to do when GPDB is running slow in order to identify queries that are slowing down for the database? Is that Barath back there I see with Oak? So the first thing I normally do is I go in and look and see if there's any long-running queries. So if the system starts running slow, usually what's happened is some has been sitting there for a long time. Those are usually my first culprits that I take a look at. I'm trying to think of next on top of that.
Yeah, I mean, usually it would be CPU usage or CPU or memory are the main culprits in this case. So you could probably just set up some rules using Workload Manager to see if any particular queries are exceeding these thresholds, arbitrary thresholds that you set. From there, you might be able to identify high resource consuming queries that could either bog down their load or even.
Right. So the other, just generally, the first question would be is, what's the status of your system if you think that it's running slow? So number one, if you look at the command center or any system monitor or any of is the system overloaded in terms of, is it topped out in the CPU? Is it crashing on I/O? So, as a general rule, you would first take a basic look at the system. And then to Barath's point, if you identify that you think it's specific queries, then it's a matter to drill down and see, is there one query? That's the easy problem if it's just one query. I think the harder problem is when it's just like they call it in medical, metabolic syndrome, overload of everything. When people are doing, let's say they're doing replication and doing 30-second updates constantly into the database and you're just thrashing I/O. So if you're lucky, it's just one query and you can find out what it is. And it's not just a complete overload of just letting too much stuff go.
I'd say that question, I think, kind of in some of the talk that happened was one of those important things when we talk about Greenplum database. It doesn't really exist on its own. So when you're standing it up, it's important to have a bunch of monitoring systems in there to know how the disks are doing, how the systems are doing. Ideally, if things are running slow, if you're an admin, ideally you know already that a disk has failed or something has gone wrong. And to be able to figure that out and don't have your users coming down and then you have to run GP state to actually figure out that one of your systems is slow. So as you're starting deploying a Greenplum cluster, make sure that those monitoring pieces are a part of your infrastructure too. Because Greenplum doesn't monitor the hardware, you need to have another system in there to monitor the hardware to make sure that it's healthy.
The other thing I would say on the performance slow is, this is kind of generic beyond Greenplum, but there's, change control is an important thing, right? The first question is, what's new? What's changed? Why is it running slow now? Is it a new deployment, or is it something that was running fast yesterday and today it's running slow? So I mean, then the question becomes the debugging of, okay, well, what's changed between today and yesterday? Right? Is the hardware healthy, as Scott said? Is new users? Is it a system that allows ad hoc users, or is there no ad hoc users? If there's no ad hoc users, did the data size change, right? Are we loading more data? Let's say we're loading data from weblogs. Did we get more weblogs because it was the Olympics? That used to happen in Yahoo News, right? All of a sudden the jobs would take forever. That's because there was some event. So what's changed is a critical question. And then what percentage of your system is ad hoc versus planned? If it's ad hoc, how do you control the ad hoc? Do you have any process in place to monitor and control new queries that people are just deciding to ask today?
So I see two questions that popped up there. One from Caesar saying, I see more community downloads coming from software startups. Can you explain why Greenplum database is attractive to software startups? I'll let everybody else chime in. My feeling on that one is you get a lot of software startups out there. that are using open source technologies, and they might have a database like Postgres, and then they run into an issue where they are getting more data now that they're trying to process, and they start looking for a new system to do that. Greenplum is a real natural transition from Postgres into the big data world, and it's fairly easy to get up and running at small scale as well as at large scale. So I think that's why, and it's got a low barrier to entry. I mean, if you know Postgres, you can really get into Greenplum and do stuff and test things out. It's not learning a whole new paradigm of how to do things. So I think that's one of the reasons why it's attractive to startups. What's other people's opinions on that?
Yeah, I would think the open source piece is pretty big now, especially since there's a lot of newer open source projects that don't really have the production usage in big name companies that Greenplum had as a traditional closed source product, right? So once we went open source, now you sort of had the best of both worlds. So it makes it much more attractive to some of these companies because they know it's been vetted in much larger enterprises. There's a new one. Is there a way to configure more than one mirror seg?
Oh, I didn't see that one. Okay. Ivan, you want to take that one?
Sure. Basically, no. The Greenplum mirroring is one-to-one, one primary, one mirror. And that's probably the way it will be for a long time. As we converge Greenplum with Postgres, I believe that Postgres replication does have multi-mirror capability. And that's, so if you look at the overall long-term vision for Greenplum to be a data warehouse on top of the Postgres open source single node database, that potential is there for us in the future, but it's not, there's a huge amount of engineering work to get from point A to B, and so it's not anywhere in the near term framework.
It might be worth covering just a little bit about what we're doing there, Ivan.
Sure. So again, if you go back in time a bit, around 2005, there was a bunch of companies and startups creating data warehouses on top of Postgres, and we all kind of, including Greenplum, and we all forked off of Postgres back in around 2005, Postgres 8 dot something or 7 dot something. A lot of the different vendors decided to go completely different directions and really just build their own database. But from the Greenplum point of view, we are committed to embracing Postgres and making Greenplum aligned with the Postgres project so that we can build data warehousing and continue to benefit, and the Greenplum community benefits from the Postgres work. And so basically we're doing proactive merging of Postgres code back into Greenplum with a vision to align these two technologies and to have Greenplum in the long run be running off of the latest Postgres. And then providing the data warehousing and machine learning and data science and big data capabilities to build a full system out of individual Postgres. So that's the project we're doing, but we're doing that at the same time as making our customers successful and our users successful. So it's not a hair turn move where we just completely change direction, but it's a gradual approach towards that North Star. And we're continuing to have more Postgres stuff and more of the latest Postgres stuff in GPDB.
Getting back down in the chat here.
Yeah, we're talking about stats now.
Yeah.
So the question was, at the end of loading, we run statistics. We run analyze to make sure the statistics are fresh. And I guess the point that Bart was making was that if you see unpredictable behavior, that could come from the stats change, right? If you get all of a sudden slower queries, if you had new statistics, that would generate new query behavior. And then Danilo is saying, got it, but we run, right after we change the data, we run the analyze to make sure it's fresh. Scott, anything you want to add to that?
I guess I'd just say that that's one of those balance points, right, where you kind of have to look at it. Running analyze all the time is probably more overhead on your system than you want to do. Analyzing your data, if you can, is fantastic. Keeping your stats up to date the best as possible is kind of where you want to be, but you also want to balance that. So, you know, don't insert, if you got a 1,000,000 row table and you insert 10 rows, you don't have to analyze at that point, right? You might want to shoot for, I'm not sure what the benchmark is, maybe 5 or 10% of your data, or if you're adding a significantly different chunk of data to what you have,
Right.
you know, do an analyze at that point in time.
Ask Daniello, when you say you run stats at the end of each loading job, I assume what you mean is you're running stats for the new data that you loaded. You're not rerunning stats for all the existing data and getting into the case where Bart said where you're getting new stats across old data. Is that right, Daniello? What do you guys do? Here he comes with an answer. And I guess this raises another good question, which is you walk into guy walks into a bar, and I'm just kidding. A guy walks into a Greenplum customer. What's the first like three or four things you would check to make sure they were taking care of the system? Like, would you?
Well, stats would definitely be one of the top ones there. When was the last time you analyzed your system? And I would say that the preferred way for stats is to have them where everybody runs stats, so you're not making the system do it itself, but sometimes it's better to do that for the system. I think that's the top of my list is when's the last time you updated all your statistics on your system?
Okay.
What about GP check perf, Scott? Just the health of your system, and do we publish kind of minimum expected requirements around those numbers that check perf outputs?
I don't think we have a minimum expectation around them. We have some numbers where we think things should hit to get decent performance. And that's the thing of being software. You can run it on much lighter stuff, but the results that you will get will not be as fantastic as if you're running a big cluster. But I would say check perf is important. One of the main reasons to run check perf is to ensure your things are running in parallel. That would be one of the next things I would check would be how's your system set up, right? Are you running 8 nodes that are dual 12 cores, and then you have 2 nodes that are dual quad cores with 8 gig of RAM and trying to run a parallel system on hardware that's not parallel, or if things failed over and then they're in a weird configuration at that point in time. That tends to cause a lot of pain in systems. So you try to keep things as parallel as possible. And GP check perf is a great way to see, because sometimes you have all the hardware is the same, but you might have an array of, and I ran into this personally, I had an array of disks that didn't say a disk was failed, but it ran 40% slower than another array of disks. And the only way I picked that up was by running GP check perf a few times and saw that the array wasn't up to snuff with the other arrays, creating a non-parallel system. So that's where having check perf stats and running it across the system is a good way to benchmark your system and see where things are at. You should run a check perf before you get your system up and running to know what your kind of gold standard is. To say, hey, when everything's down, I should be able to hit 2,000 gigabits per second of I/O throughput. So that way, 3 months down the road, when the system has problems, you can run it again and know what your gold standard is and know where you're at in comparison to that. So GP check perf is another great idea.
So the question that Vish asked was, why does the docs say that you need to have 10 gigabits interconnect, and is that required? And so there's a bit of history there. If you go back to about 2010, our preferred platforms all had 4 1 gigabit NIC cards. And when we released Greenplum 4, which was in 2010, had a higher network requirement than Greenplum 3. And in order to ensure that customers didn't go down in performance, they needed to have enough network throughput to especially on data loading, because we were introducing a new form of mirroring. And so we found that with 4 1 gigabit networks, they weren't able to keep up with the data loading in many cases. So that's the history of that, and why we said that in order to be a commercially supported system, that we recommended 10 gigabit network. Now that being said, if your performance is okay with the 1 gigabit and you're not migrating from one version to another or one system to another, and you initially test it and it works fine, and you're not pushing the load heavy, and you don't see the network getting bottlenecked, then there's no issue. So you can feel free to use 1 gigabit, but unless you're running VMs, if you're running VMs with like only a couple cores, then maybe that makes sense. But if you're running 2 full CPUs and you have the full power of commodity servers, I would highly guess that gigabit would bottleneck.
Also, one of the issues that you run into with gigabit, and I saw this I had a 4-node cluster at one point in time that ran on bonded single gigabit interfaces, and it was fine. We took it up to, I think it was an 8-node cluster, and it started to fail. We also tried to do, like Ivan said, we tried to do a 16-node cluster on 4 individual 1 gig connections. And the problem that we ran into is there's a buffer at space that as packets come in, it's going to buffer data up. On a 1 gig connection, that buffer is not very big. So when you have a query that's going to take everything and write it across the network to a single, like you do a unique, right, where it's got to congregate all the data in one place. You have 16 nodes, throws everything at one gig network connection with a small amount of buffer space, it tends to blow it up. That's one of the things that 10 gig gives you, is a lot bigger buffer space to handle that data coming through, as well as increased throughput. So that's really why once you start getting to bigger clusters, that seems to become more important.
Okay, good. So there's a couple more questions came through here. First of all, to finish off with the statistics, I think Daniello confirmed that at the end of the job, they just analyzed the table they loaded. So I think that is best practices, right? As Bart said, you don't want to reanalyze the whole database after doing 1 day's load. You just want to get the new statistics for the new data. So that's perfect. And then next question was from, I think that's Ron, right? If I'm not mistaken, that must be Ron from Buffalo, New York. So Ron is asking about vacuum analyze or vacuum separately from analyze. I personally have dealt with this before and would recommend doing vacuum separately than analyze, because there was a rumor that it runs faster if you run them together, but in reality it just runs vacuum and then it runs analyze.
And if you haven't, I guess in running analyze is talking about that. If you haven't looked at analyze DB when you're trying to analyze like an entire database, really take a look at the analyze DB utility that can parallelize the amount of analyzes that you have running at once. That's a great utility to use. Comes with the distribution.
Yeah, and that one's external to the PSQL interface, right? It's just a command line option. And you can change the parallelism across that to sort of meet the hardware you have if you don't want to max it out.
So I see the question, does that apply to vacuum DB? I don't think we've parallelized vacuum DB. Can we get a definitive answer on that one? And we've got another question out there that's, let's see here, on resource queues. So we have the impression that if there are less resource queues in usage at the same given time, we should see better performance. Recently, we decided to group all access from front-end users into a single resource queue instead of all three. All users have the same priority. Is this correct? Let's see here. I'm trying to think how I would answer that one. Resource queues are another great it depends kind of question. It's situational. I'm going to say that's probably your best bet there is you've got front-end users in a single resource queue. That's probably going to be better than trying to break them all up and giving them specific resource allocations for all the little resource queues. One thing I might look at in there is if you have like specific people that are outliers. Like I think a single resource queue for web users would be good. If you have an outlier that's somebody that's doing like massively large queries, ideally they're not doing that from the web though, right? You might put them in a specific queue, but I wouldn't go about divvying up special queues for, if you got 15 different web apps, I wouldn't make 15 different queues for all the different web apps. I would group them into one. Because you can get kind of crazy with resource queues and trying to divvy up all the processing and management of all of that generates a little bit extra overhead. And I think the additional thing there is if you have them in a resource queue, ideally if you have some web users that are busy at one point of the day and not at the other, those resources can shift back and forth, as opposed to if you have a bunch of individual resource queues, they might be consistently hitting the cap during the hour or two that they run, whereas if they have a larger resource queue that's part of a group, they would be able to flex a little bit more inside that resource queue. And yeah, I think the queue approach with the low, min, medium, high, and max queues is good. I would be very cautious about using in Greenplum database. If you got a priority of max, I would be cautious about using the max priority. On the CPU scheduling side, there's kind of a line between like the min, the medium, and the large. I can't remember what they're called by default. And they're like a quarter, 1, and 2x. But then when you hit the max one, which is like what GPadmin stuff runs at, it's like 1000x, right? So he basically gets all the cookies and nobody else gets anything. So I'd be really careful about using that for special situations, extremely special situations, not because, well, these guys are power users and they're running stuff all the time. We just keep giving them max and end up with a bunch of people having that, because they'll tend to monopolize the system if you hand that queue usage ability out a lot. Yep, big difference between high and max, definitely. So stay out of max as much as possible. High is okay. So I was saying, as far as web stuff, that I think grouping them all together for web users would probably be better, allowing users to flex back and forth as opposed to having a single queue for a bunch of people. Maybe that's a question you guys that work with the internals more can answer. Is there an advantage to having, resource-wise, is there an advantage to having 15 users in one queue as opposed to having 5 queues with 3 of those users in each of them? Okay, so I think the deal was I'm an enterprise and let's say I have 15 web apps. My suggestion was that you shouldn't make a resource queue for each web app. That's kind of overkill. I would suggest combining them down into kind of one queue unless there's a special type of user within that. As far as the system is concerned, is there an advantage to having 15 users in one queue versus having 5 queues of three users for different apps? I mean, would you get better performance out of that?
I think there is an advantage, Scott, to combining them. Can you hear me well?
Yes.
Okay. So one of the problems with slicing it down to so many queues is that you have to allocate memory to each queue. And I've seen folks who, if they start creating 25, 30 queues, they end up just running out of memory. They don't have any memory to give to the queues. So why do we have the queue? We have the queue to control the concurrency, right? So if we're saying here's my cluster and I want to allow no more than 25 users, then instead of creating 25 queues, let's just create one and only let 25 queries go at once. Now, if you have different policies for different classes of users, then okay, fine. So you need to say I have some really critical queries that need to be in this queue and some lower priority queries in this queue. But once you start getting into like 10 classes of queries, I think we're overthinking the problem, right? We're creating structures that aren't adding value, right? The value is control the concurrency and differentiate the personalities of the users. So in the end, you can have maybe a couple, let's say you had 3, high priority, medium priority, low priority, and this amount of concurrency, and then put those guys in those buckets. But once you start breaking it into small pieces, then there's not enough meat to go around for everybody. Right?
PostgreSQL is releasing 9.6 beta. How different is Greenplum from Postgres in the latest versions, and what specific Postgres features is Greenplum adopting in the open source?
Well, so like I mentioned in the previous comment, there's the direction and then the status, right? So the overall direction is to align to Postgres Greenplum and to continue to bring newer versions of Postgres and later Postgres technologies into Greenplum. But there's a timeline required, right? So it's not something, it's not a thing where we're just merging the code into one system overnight. So the bottom line is that the stuff that's in 9.6 is not yet in GPDB. There's some new stuff coming in Greenplum 5, like JSON data types, raster geospatial, unique identifiers, some of the new post-PG SQL syntax, anonymous code blocks, and a few other stuff. And it's a decent chunky, Postgres modernization, but it's by no means a complete to the journey. So there's a long way. 9.6 is just out of the door, and so although we have that vision to go towards latest Postgres, it's not something that is day-to-day current. So GP5, I would say approximately would be coming out in the first half of 2017. So it's a major release. So it's not on a, we're still doing roughly monthly minor releases on Greenplum 4.3 and trying to continue to incrementally improve that. But Greenplum 5 won't come till the first half of next year.
I've seen the question pop up a couple of times on disk usage limitations. I know what I did in the past was I had a weekly email that rolled up all the schemas and how much data was in each schema, and users were locked onto a schema, and then there were like the production pieces that they were in. And I would go upstairs and complain at them and say, hey, you're using 2 terabytes, that's way too much, you need to cut it down. And then the data scientist would say, oh, sorry, I'll delete half my data, I don't really need it anyway because it's been out there for too long. Are we doing anything on disk usage limitations?
So Scott, what you said is exactly what I said when our microphone was on mute by accident. So those types of reports are fundamental to the operation of disk-based monitoring right now, and then going and kind of whacking users over the head for taking too much space. We're looking at potentially dynamically doing that with the workload manager, but not necessarily doing that. And as we mentioned, Postgres itself doesn't have disk-based quotas, so that would have to be a custom Greenplum feature. So it is very highly requested feature, but for now we're really relying on just the monitoring perspective more than proactive quotas. The other thing that you could do straight away if you wanted to would be to create file spaces and to use the operating system and say, here's the disk partitions, this is set out for this schema or this table space, and to have that only used there. But that means it's a lot of overhead to change, and so most people don't do that. So in reality, most folks just do what Scott said exactly, which is writing disk-based reports and then following up with the users thereafter.
I guess that goes into why it's also important to have system alerts. As part of what we did before, we had alerts that went out at the OS level, if partition utilization went above 60% or 70% or 80%, right? We had a guy that did a CTAS on a table that took up 40% of one of the databases. and tried to scarf that into another one. And where we caught that at was in the system admin group, seeing this big spike in data utilization on all the servers. And we ran up there and, you know, smacked them around with the band hammer a little bit and said, hey, what are you doing? So it's important to have all those different pieces in your ecosystem to make sure things are running right.
All right. We are actually coming up towards the end of the time. We have time for one last good question.
Looks like Ron is trying to type something out there.
Yep.
Oh, Michelle, beat him to it.
Oh, Impala. Yeah, we have to cover this one.
We're migrating our Impala cluster to Greenplum, which is why our hardware is configured Hadoop-like and doesn't have 10 gig. Our internal benchmark shows GPDB to perform better. Is this common, or is Impala a more common migration path? Impala to Hawk, a more common migration path? I think I'll let Dan take that.
I would say, I mean, we've seen some Impala to Hawk. A lot of times, what people are seeing is maybe they went with SQL on Hadoop, and then decided what they really wanted was just an MPP data warehouse and all the wonderful features that brings. And then when you have that with the scalability of something like Greenplum, it makes it a nice solution. So I wouldn't say that's an uncommon. I'm seeing a lot of people sort of making that realization. But there are still those people that go down one road with SQL and Hadoop and just want to change to another one to see if that helps, right? And yes, that change to Hawk can and will affect performance and help performance. But then there's those other features, indexing updates, things like that you're going to get with Greenplum. They're just going to make it a much more rounded solution if what you really want is a data warehouse.
And Michelle, to your point, the question is you may not be getting the full benefit of Greenplum if you're using a 1 gig network and using something that was, you know, kind of built for Hadoop. Even if it's working for you, you might be able to get benefits in the future. And I guess one of the key questions would be is how big is your data? Like, is this a kind of like a 10 machine or a 20 machine or a 200 or 1,000 machine cluster, you know? And if it's really on the smaller side, you could probably optimize and get some, you know, some hardware which is, you know, optimized better and see gains in the future. And then, you know, there's a few varieties of that, whether, you know, you're using VMware or you're using bare metal. So it's 20 machines. Yeah, for a 20 machine cluster, if you start doing a lot of non-co-located joins and doing a lot of motion, you might find that network becomes a bottleneck. So it's something to watch. As it said in the doc, 1 gig is low in terms of network bandwidth, so it could become a bottleneck. So I'd watch that. And if you invest in Greenplum for the long run, you should look into building, you know, let's say a 10 node cluster with 10 gig. You might find that 10 machine cluster is just enough to do what you're doing, especially with the amount of storage that the machines can handle these days. It can handle almost, with 10 nodes, you can handle probably compressed data like 400 terabytes or something like that. 500 terabytes, almost a half a petabyte. So.
All right. Thanks everybody for a really great beginner's hour. I think we're gonna have to.
Yeah,
do this
no,
again.
I think it's great questions, guys, and I really appreciate the folks who signed in and came with their questions. And the time isn't, we only had a short amount of time, and we kind of got a slow start, but we